For over 50 years, if you were dealing with that awful dizziness and imbalance from inner ear damage, the advice from doctors was basically learn to live with it. That damage was permanent. That was it. But what if that settled science was just completely wrong? Today, we're going to dive into some revolutionary new science that's flipping this whole idea on its head, turning the inner ear from a biological dead end into a programmable system we might actually be able to heal.
So to really get why this is such a huge deal, it helps to remember that medical science has been wrong before. I mean, really wrong. For the better part of a century, doctors were actually recommending certain brands of cigarettes to protect your throat. Yeah, and for a while, cocaine was treated like some kind of miracle cure-all. It's a pretty powerful reminder that what we think of as solid medical fact today can, and often does, get totally overturned.
That quote just hits the nail on the head, doesn't it? We are literally living through the moment another one of those corpses is being added to the pile. And this particular subtle truth is all about one of the most delicate and frankly misunderstood parts of our body, the inner ear. Right, so for half a century, the whole field of vestibular medicine, the science of balance and where we are in space, has been kind of stuck. The common wisdom, the dogma, was that the tiny little hair cells in our inner ear, the ones that turn movement into balance signals for our brain, they just couldn't grow back. Once they were gone for good. The inner ear was treated like a black box, a sealed-off part of the body that you just couldn't fix. And you can imagine, this created this cloud of hopelessness for millions of people. All the treatment was focused on coping, on compensating for the damage, but never, ever on actually repairing it. Patients were just told to get used to it. Well, that era of just giving up is finally coming to an end. And then, everything changed. The big breakthrough came from research that showed the inner ear isn't a sealed black box at all. It's what scientists are now calling a programmable landscape. And trust me, this one idea changes the entire game. So what on earth is a programmable landscape? It means that the support cells that are already inside your inner ear are basically just sitting there, waiting for the right set of instructions. Think of it like a garden where the seeds are already in the soil, but they need the right water and fertilizer to actually sprout. Well, the cells are the seeds, and these special molecular signals, they're the key. If we can give them the right signals, we can kickstart the body's own regeneration process. This is the big shift. We're moving from just managing symptoms to actually going after a cure. Okay, to really wrap your head around how this programming works, we gotta meet the two main characters in this whole process. Let's imagine the inner ear is a super complex construction site. The orders are being given by two master proteins. The first one is a pathway called Wnt. We're gonna call it the architect. The second is a protein called Notch. That's our site foreman. First up, you've got Wnt. Think of Wnt as the architect. It has the blueprints, and it gives the final green light. It tells a regular old support cell, hey, it's time to transform into a super specialized hair cell. But, you can't just have everyone start building all at once, right? That's just chaos. And that's where our site foreman, Notch, steps in. His job is to manage the crew and make sure there's no overbuilding. So how does our foreman, Notch, do this? Well, it's this really cool process called lateral inhibition. As soon as a cell gets the signal from the architect and says, all right, I'm going to be a hair cell, it basically reaches out and physically taps its neighbors on the shoulder. That touch sends a really clear message. I've got this job, so you need to stay put and be a supporting cell. And boom, you get this perfect, stable structure, this beautiful mosaic of different cells that's absolutely critical for the whole system to work. Now, this whole process is amazing, and it works perfectly when we're first developing. So here's the billion-dollar question. Why doesn't this repair process just happen in adults when we get an injury? Why does the construction just stop? Well, the answer, it turns out, is that we've got an overzealous foreman. It turns out that in a grown-up ear that's been damaged, that notch protein, the foreman with the stop sign, is being produced at 2 to 3 times the normal level. So the foreman isn't just managing the site anymore. He's running around with a megaphone, constantly, relentlessly screaming stop at everyone, and that prevents any new construction from ever getting off the ground. The whole system is just locked, frozen. The stop signal is jammed in the on position, and it's forbidding any of the nearby cells from becoming the new hair cells the system so desperately needs. So what's the fix? Well, it's actually kind of brilliant in its simplicity. Scientists can use these things called notch inhibitors. You can think of them as giving noise-canceling headphones to the foreman. By just temporarily silencing that constant stop signal, it allows the architect's plans, that Wnt signal, to finally get through again.
and the rebuilding can finally begin. But hold on, it's not just about telling the foreman to take a break. Think about it. Any good construction project needs raw materials, it needs power, it needs a safe environment to work in. It's the exact same thing here. For this to work, we have to prep the microenvironment of the inner ear for the big rebuild. Okay, so there are basically 3 big things we need to get right here. First up is microperfusion. We've got to boost blood flow to get all the supplies in. Things like flavonoids, the stuff in berries, and dark chocolate are great for that. Second, mitochondrial coordination. Building new cells takes a ton of energy, so nutrients like magnesium and Q10 are key to making sure the cellular power plants are running at full steam. And finally, oxidative homeostasis. A damaged ear is an inflamed, hostile place, so we need powerful antioxidants like resveratrol to protect those delicate new cells while they grow.
Okay, so this science is, it's just mind-blowing, and it's moving from lab experiments and animal models towards being a real thing for people. But like with any massive breakthrough, there's still some pretty big hurdles to clear before you can walk into a clinic and get this treatment.
So, what are the big puzzles scientists are still trying to solve? Well, first, they need a perfect way to deliver these signals to the inner ear, which is really hard to get to. Then, they have to pulse the signals just right, enough to get repair, but not so much that you get uncontrolled growth. And, of course, these brand new cells have to connect properly to the vestibular nerve, or they won't do any good. And finally, doctors will need to figure out exactly which patients are the best candidates for this kind of therapy to get the best results.
Really, what this all boils down to is a complete change in how we think about this problem. For decades, the goal was just to help patients compensate for a system that was failing. Now, for the very first time, the goal is to provide the biological tools to fuel the body's own success, to help it rebuild itself from the inside out.
So all those years of being told just live with it, they're over. The inner ear is not some mysterious black box anymore. We have the blueprints. We know how to manage the construction crew. The big question we're facing now isn't if we can rebuild our balance system, but simply how soon? How soon until this is changing millions of lives for the better?